Hi, in this question they're asking you to find the volume of the solid form by revolving the region bounded by the graphs of y equal to 9 minus x, y equal to 0, and x equal to 0 about the x-axis. Now, let me show you how do you do that. First of all, look at the line y equal to 9 minus x. Let's write y equal to 9 minus x. Where is the x-intercept and the y-intercept? If you find the x-intercept and y-intercept by replacing x by 0 and y by 0, so you get the x-intercept is when y equal to 0, so you put 9 minus x equal to 0, then you can find that x is equal to 9. And from the graph, you see that x equal to 9 is the x-intercept. Similarly, we can find the y-intercept. So the y-intercept is when x is equal to 0, which means that y is equal to 9. So here is the y-intercept. And to find the required volume, we can use the disk method, which means that we need to integrate the areas of the disks formed by revolving the region bounded by the curve y equal to 9 minus x, the x-axis, and the y-axis about the x-axis. And you can see that the region we need to revolve lies between x equal to 0 and x equal to 9. And to make the shape familiar for you, this is one of the disks formed when rotating the line around the x-axis. And if you imagine the figure, it's going to be an infinite number of disks attached from 0 to 9 to form this region. And if we calculate the volume of one infinitesimally thin disk, we can calculate it by the formula pi r squared dx. Let me write it for you. It's pi r squared dx. What do we mean by that? R is the distance from the x-axis to the function, which if we take like a value x, then this would be represented by f of x. So if we want to calculate the volume, so we can say volume is equal integral from 0 to 9 for pi f of x squared dx. This represents the volume of the region they are asking for, which means that this is going to be equal to integral from 0 to 9. Let's make pi outside and replace f of x by 9 minus x, which is the y that we have at the top. So we say that it's equal to 9 minus x squared dx, and then we can find this integration and we get the volume. So if we simplify it, we can say it's equal to pi integral from 0 to 9. Let's simplify 9 minus x squared is going to be 81, 9 squared 81, 2 times 9 times x, which is minus 18x plus x squared dx. And the integral for this is going to be equal to pi. Integral for 81 is going to be 81x minus integral for 18x is 18x squared over 2 plus integral for x squared is going to be x to the power 3 over 3. And all of this from 0 to 9. And then we can replace 9 the first time in all of the expression. We write pi into 81 times 9 minus 18 over 2, which is 9, so you get 9 into 9 squared plus 9 to the power 3 over 3. We replace 0 in all of the expressions here, you get 0, so that would be 0. And by using the calculator, you will get the final answer as 243 pi, and that's it. Let me show you another example. Here they are asking you to find the volume of the solid form by revolving the region bounded by the graphs of y equal to 4 minus x squared and y equal to 2 minus x above the x-axis. Similarly, we can apply what we did before, but here they are asking you for the region bounded by the graphs, which is this part. So in this case, we can apply what we did before twice, and we subtract the volumes. But we can do that in one integration. So what do? We say the volume is equal to pi integral from a to b, the big radius squared minus the small radius squared dx. But first, we need to find the points of intersection between the two curves. And to do that, we can equate the two functions. We can say 4 minus x squared is equal to 2 minus x to find the points of intersections between the two curves. Now, working with that, we can say 4 minus x squared plus x minus 2 equal to 0. We bring everything to one side. Simplify it, you get minus x squared plus x, 4 minus 2, which is 2, which is equal to 0. And we can multiply the whole equation by negative. It becomes x squared minus x minus 2 equal to 0. And we factorize it. You get x minus 2 and x plus 1. Also, you can do that on the calculator if you have calculator. You can get that x is equal to 2 or x is equal to minus 1. So we found that the intersection between the two curves is at x equal minus 1 and x equal to 2. Then we say that the volume is equal to integral. We keep pi outside, big R squared, which is represented by 4 minus x squared all squared minus the inner radius, which is represented by 2 minus x, and we put squared and all dx. And all of this integral is going to be between minus 1 and 2. And you can simplify it and complete the integration, or you can put it on your calculator and find the integral, and then you will get 108 pi over 5. And that would be the final answer. Another example. Here they are asking you to find the volume of the solid formed by revolving the region bounded by the graphs of y equal to radical x and y equal to x squared about the x-axis. As you see that this is the curve representing y equal to radical x, and this one representing the function y equal to x squared. And they are asking you to find the region bounded by the graphs, which is here, rotating around the x-axis. First of all, let's find the intersection between the two curves. So we can put y equal to y, which means that x squared is equal to radical x. And to find x, we can square both sides. You get x to the power 4 is equal to x. Bring them to one side, you get x to the power 4 minus x is equal to 0. Taking x as a common factor, we say x bracket x cubed minus 1 equal to 0. And you can get that x is equal to 0 or x cubed equals to 1, which means that x is equal cubic root of 1, which is 1. We found the point intersection between the two curves, which is at x equal to 0 and at x equal to 1. And then we can apply the same procedure we did in the previous question. We can say that the volume is equal to pi integral from 0 to 1, the outer radius square minus the inner radius square. So the outer radius square is radical x all squared minus the inner radius, which is x squared squared dx. Now, if you want to know which one is the outer radius and which one is the inner radius, you can take any point between 0 and 1, let's say 0.5, replace it in x squared and replace it in radical x. So if we take 0.5 and make it square and 0.5 make it radical, you check on your calculator which one gives you greater value, and that would be the outer radius. If you try it, you will find that radical 0.5 is bigger than 0.5 squared, and then you can put the function radical x for the big R and x squared for the small r. And then we simplify the expression. We say pi integral from 0 to 1 radical x squared, which is x, minus x squared squared. You get x to the power 4 all dx, which is equal to, and we put pi. And what's the integral for x? It's x squared over 2 minus, what's the integral of x to the power 4? It's x to the power 5 over 5. And all of that from 0 to 1. Now replace 1 for x the first time. You get pi into 1 squared over 2 minus 1 to the power 5 over 5 minus, replace 0 now, you will get 0 squared over 2, which is 0, minus 0 to the power 5, which is 0. And simplifying, you get 3 pi over 10, and that would be the final answer. Look at this question. They are asking you to find the volume of the solid region generated by revolving the region bounded by y equal 1 minus x squared and y equal to 0 about the line y equal to 3. Now, if we look at the curve now, this curve represents y equal to 1 minus x squared. This line, which is the x-axis, representing y equal to 0. And the line y equal to 3 is in blue here. So in this case, we are going to find the volume of the region rotating around the line y equal to 3, not around the x-axis. So the axis of rotation is going to be this one now, y equal to 3. Let's find first the intersection between the curve and the x-axis. So we can say 1 minus x squared is equal to 0, which means that x squared is equal to 1, which means that x is equal to plus or minus 1, which is plus or minus square root of 1. So those are the points of intersection. And then to find the volume of revolution, we found the outer radius and the inner radius. Which one is the outer radius? The outer radius is the distance between the line y equal to 3 and the x-axis. This is bigger than the smaller radius, which is the inner radius that connects the line y equal to 3 and the graph. So what do we say here? We say the volume is equal to pi integral from minus 1 to 1, the values that we got here. And now the bigger radius, let's write the outer radius squared minus the inner radius squared dx, which is equal to pi integral from minus 1 to 1. Now, which one represents the outer radius? It's the distance, as we mentioned, between the x-axis and the line y equal to 3, so which means that is going to be equal to 3 squared minus, and the inner radius is represented by what? It's the distance between the line y equal to 3 and the graph of the function y equal to 1 minus x squared, which is equal to, let's say, 3 minus 1 minus x squared is going to be equal to 3 minus 1 plus x squared, which is equal to 2 plus x squared. We replace it here, we write it's equal to 2 plus x squared all squared dx. And then we complete the integration and we find the answer. Now, to find the answer, either we simplify the expression and we calculate the integration, or we can put it on the calculator and we find that it's equal to 104 pi over 15. Let's do another question. Look at that. Here they are asking you to find the volume of the solid region generated by revolving the region bounded by y equal to 4 minus x squared and y equal to 2 plus x squared about the line y equals to 4. As you may see from the graph, this is the graph representing 4 minus x squared, and this one representing 2 plus x squared, and this is the line y equal to 4. Now, to do that, as we did previously, we need to find the points of intersection between the two curves. How to find it? We equate the functions. We say 4 minus x squared is equal to 2 plus x squared. We solve this equation. We bring x's to one side and numbers to the other side. You get minus x squared is equal to 2 minus 4. Here we have minus 2x squared is equal to minus 4, which is minus 2. Divide by minus 2 by minus 2 on each side. You get x squared equals to 1. And then x is equal to plus or minus square root of 1, which is equal to plus or minus 1. So now we know the boundaries for the integration, but we need to find the outer radius and the inner radius. So to find the outer radius, let's say the outer radius is going to be equal to the line, which is 4, minus the graph which is away from the line. Which graph is more distance from the line? It's the graph 2 plus x squared. So we say 4 minus, bracket, 2 plus x squared, which is going to be equal to 4 minus 2 minus x squared. Simplify it, you get 4 minus 2, which is 2, minus x squared. And the inner radius, which is the smaller one, is going to be equal to 4 minus the function which is closer to the line. Which function is closer to the line between minus 1 and 1? Is going to be 4 minus x squared. Simplify it, you get 4 minus 4 plus x squared, because we have minus times minus, which is going to be equal to x squared. 4 minus 4 cancel. And we do the volume then. We say volume is equal to integral between minus 1 and 1, and we have pi outside, and inside we put the outer radius squared minus the inner radius squared dx. And we replace, and we say it's equal to pi integral from minus 1 to 1. Replace the big R is going to be equal to 2 minus x squared all squared minus the inner one, which is x squared all squared dx. And then we put it on the calculator and we solve it, and we get it equal to 16 pi over 3, and that would be your final answer. What about the volume rotating around the y-axis? Here the question says that find the volume of the solid formed by revolving the region bounded by the graphs of y equal to radical x, y equal to 4, and x equal to 0 above the y-axis. We can do similar process to the previous questions, but we change the variables. Instead to be of y in terms of x, we can make it x in terms of y, and we make the integration bounded on the y-axis, not on the x-axis. Let me show you what I mean. Here we have the function y equals to radical x. Let's find x in terms of y. So make square on each side. You get y squared equal to x, which means that x is equal to y squared. This is the first one. The second one, y equals to 4, is already done. Y equals to 4. And we have x equal to 0, which is the y-axis. Now, the points of intersection between the graph x equal to y squared with the y-axis is when x is equal to 0. So we say y squared equals to 0, which means that y equal to 0. So we know that the integral that we're going to find is between 0 and 4, but we need to find the outer radius and the inner radius. What is the outer radius? The outer radius, which is r of y, is going to be equal to y squared, and the inner radius is going to be equal to 0. Then we can find the volume is equal to integral from 0 to 4 pi outside 4y squared minus 0 squared. But here, remember, it is with respect to the y-axis, so we make it dy. Now, if we calculate it using your calculator, you're going to get 1024 pi over 5. Just a small note here, if you don't want to calculate the inner radius, you don't need to do that also. Why? Because we have only one curve rotating around the y-axis, so you can use pi integral from 0 to 4 for y squared. And as you notice that the inner one is equal to 0, so it is ignored. And this is all for now for volume of revolution. I hope you liked the video, and bye for now.